Anyway, let's get close to the box and see if the prompt appears. It does. Hello everybody and welcome back to Learning and Understanding Blueprint. In today's episode, we're going to be covering functions, and since that won't take too long, we're then going to transition into creating an interact system. After today's tutorial, you'll be able to confidently create your very own interact system for a first-person game. You could easily use it in third person and other areas as well. Let's go ahead and hop in. To start, we're going to show you some of the limitations of custom events and why you might want to use a function instead. In a lot of cases, you might think that creating a custom event for something that you're going to be calling a lot is smart. So for example, if we take a look at what I've got on the screen, we've got event 1 that has an array of things and a current address. We have event 2 that also has an array of things and it has a separate address. And then we have a event here that we created called add1. We did that because we want each of these events to be able to cycle through their arrays by updating their current address. And instead of doing like 3 nodes every single time in order to add one, we thought we'll just create a custom event so it does it in 1 node instead of multiple. Pretty smart, right? Well, you're about to see the limitations of custom events. So let's go ahead and just get a copy of whatever's in here for both of our arrays. So get a copy. Now, obviously we're not actually going to do anything with the copy in the example here because there's nothing in this array. So we can't actually do anything with it. Or you know what? Let's just make it destroy actor. So just so there's something to connect to it, right? So basically these 2 events destroy the actor that they are currently selecting in the array. We did something very similar to this in the previous episode where we had an array. We had the current address, which starts at 0 because it's an array, and then we would add 1 to it to go to the next thing. So after we destroy whatever actor is in position 0, we created this custom event down here so we can add 1 and not have to do like 10 nodes, because if you remember, if we were to add 1 normally, we would get the current address, we'd pull this out, we would type in add, we'd have to press 1, then we'd come over here, and then we'd have to set it, blah, 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 blah. But instead of doing that, we were like, let's just make a custom event that does it for us, and then we only have to do 1 node, much simpler. So, right, here's the number. We have an input, we need the number, so we need that current address, okay, and then we add 1 to it. So let's take this and add 1 to it, perfect. And then what we'll do is we will set, the address, just like that. So now anytime we call this, it does it for us and we don't have to do all these nodes again. So let's go ahead and pull out of event 1 and we will do add 1. Perfect. And then obviously the number is going to be that current address. Perfect. So now whenever event 1 does whatever address it's on, it will then add 1 and save it. So that way when I call event 1 again, it will already be on to the next thing in the array. Cool. What about event 2? All right, well, then what we need to do is we need to add 1, right? So that way it's going to add 1 to the address, and we need current address 2. Okay. Do you see the problem? While we were trying to make it more simple, we've all of a sudden created a really weird logistical situation. As you can see, this is saving us time in event 1. However, in event 2, it's actually going to cause us an issue because add1 is currently saving the variable for current address 1. Okay, that is a problem. We could over-engineer this and be like, well, maybe event 1 also sets another variable to true, so that way when add1 is called, we can have another input that checks that variable to see if it's true, and if it is, then it'll only do the event 1 address, otherwise it'll do the event 2 address. We could go super over-engineering, but this is the limitations of custom events. So let's replace add1 with a function. And also, just to be fully clear, this would be a silly thing to save time on, because as you can see, adding 1 without the function takes like 2 nodes, and then it takes like 2 nodes to add 1 anyway. But when we move on to the interaction, you'll see a bit more of a realistic example. This is simplified so that way a cat just jumped onto my lap with its claws. This is simplified so we can get a basic understanding first. But on the left-hand side, let's go ahead and create a function instead of a custom event. So this is our function. It's this little purple node. Imagine it as a custom event. Don't think of this as anything more complicated. It's a custom event, and you know what those are. However, it just has a couple more features that are really nice if we need them. Instead of new function, let's press F2 on the keyboard with this selected, just so you can get the hotkeys down. And I'm gonna type in add 1, just like that. Like our custom event, we're gonna need that input so we know what we're adding 1 to. I'm gonna go ahead and name that number. We're gonna leave it as an integer. Then we're gonna take that number. We are going to add 1 to it like that. And then instead of setting a variable, all I'm gonna do is I'm gonna click on add 1. I'm going to add an output. So this is our return, and I'm gonna drag the results of the +1 into the return. Now you'll see we've got 2 things here. That's because there's always a default parameter. Now, if that parameter is what you need, go ahead and use it. Just rename it so it's not new parameter. But I'm just into the habit of always just creating a new one because this is usually a Boolean, and I just like creating my own. On the right-hand side, though, if you see here, new parameter, I'm just gonna go ahead and click this X, and that will remove that. So now we have basically the exact same thing, except now it's a return node instead of setting a variable. So let's go ahead and hit save and compile. And I'm gonna return to the event graph. So on the event graph, we still have both of our events trying to destroy actors at different addresses. But instead of a custom event, what we're gonna do, these kittens are driving me insane. What we're going to do instead is call our new function. And we can either drag it out onto the event graph just like this, or we can simply just drag out and type in add 1 because that's what we named it. And you'll see that we now have an input number, but we also have that return value. So we know that for event 1, that number is the current address. However, now we have the return value of that calculation we made. So what we can do is then take and set current address like that. So now, yes, we are still setting the variable in the event, but the part where it needs to do a calculation can be used anywhere. For example, in event 2, we can also drag out, type in add 1. This time we're putting in current address 2, and then we set current address 2 with that return value. And all of a sudden, we took a set of code, reduced it down to 1 node, and then gave a return value instead of setting a specific parameter. So that way, multiple events can use this calculation method without having to over-engineer how to get the output result depending on which event calls it. Again, I know this example might seem tedious and not that great because we took 3 nodes and made an event with 3 nodes. But I'm hoping you can see past that and understand where this is going to be useful. But just in case you can't, let's move on to making that interaction system.
No ads, earlier content, ask me questions, and even get a Discord call with me to help with your game. These are all on my Patreon right now.
We are going to have to use some concepts that we haven't really used yet, but don't worry, we're going to go over them nice and slow. This video might be a little bit longer than the others. First and foremost, I never taught you how to actually add a key that the player can press to have something happen in the game. So let's cover that first. To do this, we're going to use a pre-existing file and create one new one. You'll notice in the content folder in the first person, there is an input. If we open that up, you'll see we have an IMC default, IMC weapons. This is an input map context, and we're just gonna use the default. The IMC weapons is for whenever you pick up the gun in the first person example. Essentially, you just tell the game which one to use depending on the context of the game. But don't worry, it's not that difficult. However, before we open the IMC default, we're going to go into the actions. And you'll note there's things in here that make sense. We have a jump, a look, move, shoot, and I made this one. This is the button I made for opening the store in the previous episode. I want to go ahead and right click, and we are going to go up to input, and we are going to create an input action. We're going to do IA for input action, underscore, and in this case, we're just going to put interact since we're making an interact system. Go ahead and open it up. We're going to be able to use the default values, but I at least wanted to show you one of the most important values in here, and that is the value type. You'll see that this is just a digital bool, so true or false. Well, since we're setting up a button, digital bool works because you're either pressing the button or you're not. However, if we go take a look at something like move, you'll notice that it says value type, axis 2D, vector 2D. It's simply saying that if you had a joystick, it would pick up the up and down and the left and right. So therefore, it would be 2D. Same goes for using a mouse. It would be axis 2D or vector 2D. Again, for us though, the digital bool will be just fine because we are setting up a button. With that created, go back to the input folder and open up the IMC default. And you'll see that we have a list of mappings. There's jump, move, look, and then I have store. You guys won't. But if I hit this little plus arrow, we'll be able to create an additional mapping. If you open up the drop-down menu here, you'll see every single input action that's been created. Well, we want to use the input action interact. And then we can set up different keys that we want for whenever the player interacts. You can either open up this drop-down menu and find the key that you want, or in my case, it's just a keyboard key. So I'm just going to click on this, select the key value button here, and then press F on the keyboard, and it will automatically select it for me. And that's it. I'm going to go ahead and close that, save the file, and now back in our first-person character, we will be able to right-click somewhere in the event graph, and now whenever we type in interact, you'll see there's our interact function from the interface we created. However, if you keep going down, you'll see enhanced input actions, and then we have the IA interact. And you'll see now, because it's red, we have an event that can happen whenever we press that button. So in this case, when we press F, to be completely honest, I don't remember what triggered does. Started basically just means when you hit the button, even if you hold it in, it's only going to go off once. Ongoing is going to make sure that you are continuing to press it, or it might even take it multiple times, so if you're holding the button down. Canceled would be when we released the button. Completed, again, would be just pressing the button. The reason that there's so many options for just a button is because, again, we can set these up to have different access mappings and stuff, but ours is just a digital bool, i.e. a button. So now we have a way to have the player hit a button and have something happen. However, what do we need to have happen? So basically what we need to do is whenever they press this button, so out of started, we need something to happen where it takes a look at what we're looking at and says, are we close enough? And can we even interact with that? And if we can, we'll send it a message. That's something we covered pretty early on. So we can pretty much just use the same interact interface that we created. We're just going to be changing how we send that message, because previously it was on the event component begin overlap. But instead, we're going to move that over to when we press the button, look in front of us. Is there an object there that can be interacted with? If yes, send the message. To do this, we're going to need a line trace by channel. A line trace by channel basically takes 2 points in a 3D space, draws a line between them, and then returns results on things that they hit. So if there's an actor between you and the end point, it will hit the actor, and thus we can get information based on the actor that it hit. So pulling out of started, I'm going to type in line trace by channel. Not the multi, but just the one. And you'll see, like I was explaining, it requires 2 points in 3D space, a starting point and an ending point. Well, this is a first-person game, so taking the camera's position would essentially be our eyeballs, so that seems like a good place to start the line. So on the left-hand side in our components, I'm going to pull out that first-person camera. Now, luckily, I can access its details by pulling out of the first person camera, and we can get its world location. And there we go. So we'll start our line at our face, basically. However, we need an ending point to that line. How do we say, okay, here is the start of our line, but we need it to shoot forward a certain distance? Well, in Unreal Engine, what you're looking for is something called a forward vector. And that, luckily, is also something we can retrieve from the first person camera's details. So we can get the forward vector. Think of the forward vector as nothing more than a direction. It's like saying left or right, but hyper specific because it's a 3D direction, whereas left and right would be a 2D direction. Okay, so now we have the forward vector. Well, in order to make that forward vector actually be a distance and not just a direction, what we need to do is multiply that vector by a number. That number will be the distance we want the line to go. I'm gonna pull out a forward vector. You guys know how to do math by now, and I'm gonna type in multiply. Now you'll notice it's asking for another vector. That's because whenever you do math in the Unreal Engine, by default, it assumes that you're going to multiply two of the same things, which makes sense. But for us, we actually don't want that in this case. So what I'm gonna do is I'm gonna right click on this bottom pin, and you're gonna see that I can actually convert the pin, and I'm going to convert it to an integer. So now we take the forward vector, which remember is just a direction, and we're gonna multiply it by 500. Why 500? Because I roughly know what 500 units in the Unreal Engine is in my head. It just takes experience because these aren't exact numbers, and you can play with it whenever you are messing around testing for your game. So we can't just plug this straight into the endpoint. Why? Well, think about it. This is a direction and this is a length, but we don't have a starting point. Does that make sense? As of right now, we're pointing in 3D space in a direction 500 units, but we don't have a starting point because remember, this get world location is plugged in to the start of the line. This math is to get the end of the line. But this math does not include where the camera is located. So if I was to plug this straight in, the engine is now going to assume that the end point is at 0, 0, 0 with this forward vector 500 units. Basically, whatever way the camera's facing, it's gonna move 500 units from 0, 0, 0. So in order to get this endpoint, we need to add the forward vector and distance to the world location to get the endpoint. Now it'll take the direction, go 500 units from the camera's world location. I tried to simplify that as much as I can. I hope it's not too confusing. Feel free to listen to it again as well, because I get it. It's complicated the first few times. So there we go. We press the button, and now we draw a line from our face 500 units forward. And you'll see that it returns some information. For example, it has a return value that's a Boolean. In fact, that's going to be useful. So I'm going to hold B and I'm going to click on the graph, which creates a branch, and I'm going to plug that in. This is basically just saying, hey, if this ends up being false and you didn't hit anything, don't continue the code. It's just a nice little optimization thing. The main thing we're going to be looking at, though, is the out hit. The out hit is all the information that the line gathered whenever we shot it out. So I'm going to take the out hit and bring it down, and you're going to notice that I can do something called break hit result. And now we have this nice new little node. All this node does is contain information. And if we hit this down arrow, look at all of the information that line trace can get us. Well, in this case, the only thing we really want is the hit actor, because we're creating an interact system. So I'm going to pull out of hit actor, and I am going to look for does implement interface. I think we used this in one of the first few episodes, but just in case we didn't, let me explain what this is. However, just so you know, because this takes up so much space, we can actually just click this up arrow here and it'll collapse the node again, but keep the one that we used. All we're going to do is we're going to take the hit actor and we are going to see, does it implement that interact interface that we created in episode 1, or episode 2 actually. If it does, so we're gonna go ahead and plug that Boolean into a branch. And remember, we only wanna continue if you hit something. So if you hit something, was it an actor? Does it implement the interact interface? Because if it does, I need you to send a message that we interacted, which if you remember is named int function interact. And there is that little envelope from the metaphor, and because that's how Unreal puts it on there. Awesome. You're probably thinking to yourself, but isn't this episode about functions? It is, and we're about to learn why this should be a function. But for now, let's go ahead and take a look and see if our interact system is working. So in my case, oh, sorry. You're gonna get an error if you're following along. It's because this needs a target, which of course that target is going to be the hit actor. It needs to know what to send the message to, and I just forgot to plug that in, which of course we wanted to go to the hit actor. So hit save and compile. So we're gonna go back to using the magic box. Let's go ahead and place one of those into our world. And I'm going to rotate it, I don't know, just a random amount. And if I open up its blueprint, you'll see it still has the interact interface applied to it in the class settings over here on the right. And in the event graph, you'll see that it still has the functionality we want. We are gonna go ahead though and delete the key check because we're not gonna use that for this episode. So basically, it's just saying, hey, when you receive the interact message, remember, it just squares up with the world, goes to 0, 0, 0 on its rotation. So if our interact system is truly working, when I press F, this thing should flip and be parallel with the world. And there you go. We drew a line from our face forward. It hit an actor. It said, hey, do you have the interact interface? It said yes, so it sent it a message. Also, to better show you what this does, I should have done this originally, but I forgot. On the laying trace by channel node, you can actually see that there's a draw debug. If you put this on for duration, this will show you the line while it exists. So if we hit save and compile and go back into the world, you'll be able to see how long the line is as well. So if I hit the button and then turn, you see that red line? That's the line trace we created. You see that? And then whenever it hits something, you'll note that it turns green. You see that? So you'll notice there's kind of a flaw with the interact system currently. A player wouldn't know to go up to this and press F. They would have no idea this is interactable. So let's create a very basic system to prompt the user to actually use the interact button. This is where the function's gonna be really handy. Watch as I continue this code and see if you can figure out why before I do it. For those that have never created a user interface, especially because I've never talked about it in this series, go ahead and create yourself a UI folder, and I'm gonna right click and I'm gonna go into the user interface and I'm going to create a widget blueprint. A widget blueprint is essentially just something that goes on screen for the user to see. That could be UI elements that look nice to just plain text to something invisible if you want it to be invisible. So I'm gonna click on user widget and I'm gonna call this widget prompt. I'm going to open it up and I'm going to hit save and compile immediately. I always do with new files. And on the left hand side in the search palette, I'm going to type in canvas. What a canvas does is it basically replicates the screen so we know where we're placing things. Sometimes you'll create widgets where you don't use a canvas panel because you might want the widget to show up wherever the mouse is located, sort of like a tooltip. But since this is a prompt, a canvas will be fine because we always want it to be placed in the same location anyway. So now that we've got a canvas, I'm going to add some text, and I'm going to drag that onto our canvas. Now you'll see right now it currently says text block. On the right hand side, there's some text here. Let's go ahead and just change that to press F, or whatever you want yours to say. I'm going to go down a little bit further, and I'm going to change the justification to centered, so that way it's always going to be centered in the box here. And I'll increase the size up to, like, I don't know, 64. As soon as I figure out where that's at, oh, it's under font, and we'll just change this to like 64. Nice and big so the user can actually see it. And then there's one last thing we really need to do here, is we need to change the anchor. Right now, it's anchored to the top left of the screen. That means wherever the top left of the screen is, it's always going to be that many pixels down and that many pixels right of the top left. So if we went and made this super wide, like let's say it was super wide screen, this press F is never going to be in the middle anymore. It's going to be like super far left because again, it's anchored to the top left of the screen. I hope that makes sense. So instead what we want to do is we want to anchor it to the top middle. So therefore it's always going to be the same position in the middle from the top, no matter what the screen resolution is. I'm just gonna go ahead and make sure it's just about center. And then that's it. I'm gonna press save and compile, and now we have our prompt that will show up on the screen. However, we don't want the prompt to be there always. We only want the prompt to be there whenever we are looking at something that is interactable. So if we go back to the first person character, we kind of know how to check if we're looking at something, right? We can do a line trace by channel. But currently it would just send the int function interact, and we also don't know how to make it on screen yet. So we're actually gonna have to take a step back. Let's consider how to get it on the screen first. Well, in order to do that, we have to create the widget first. In Unreal Engine, you create the widget, it stores it in memory, but it doesn't put it on screen. So you need to create the widget early on, and then whenever it's created, you can then put it on screen and take it off screen. So let's go ahead and create a custom event, and I'm just gonna call it prepare HUD, just like that. And out of prepare HUD, I'm going to, as I said, create the widget. The class will of course be the widget prompt that we created, and then for the return value, which is going to be the widget prompt it creates, we are going to promote to variable, which, as you can see on the left hand side, did actually create the variable for us. I'm actually going to rename it though, and I'm going to name it prompt ref. But let me back up. Let's think about this. Why am I making it a variable? The simple answer is I need access to this widget in order to put it on the screen and take it off the screen. So by making it a variable, it's very simple to just pull it off the left-hand side and press get. So now I can very easily access that widget, and that's why you promote it to a variable. However, we do need this to fire. We need the prepare HUD to happen on event begin play. If you remember, that's one of the first things we learned how to do. An event begin plays fires as soon as the game starts, or it spawns. And we're gonna pull out of the, which by the way, this is the event begin play. This is their logic. So we're just gonna go to the end of their logic, and we're just gonna hit prepare HUD. So at the beginning of the game, the HUD will be created, but remember that doesn't add it on screen, as you can see here. So now we need to add it to the screen whenever we're looking at something that implements the interact interface. Remember, we could use this code again, but it wouldn't quite work because this sends the message to the object that we've interacted with it, and this event only fires when we hit a button. So how can we reuse this code without just copying and pasting a whole bunch of it and have different results happen? What if we created a function that does the line trace for us? So let's do that. On the left-hand side, let's go ahead and make a new function. I'm going to call it line trace. And then I'm going to head back to the event graph. I'm going to grab the line trace by channel and all of the math we did for the start and end of the line, and I'm gonna press Control X. That'll cut it. We'll go back to the line trace function and we'll do Control V, which will paste it. I'll connect our function into the line trace by channel, and then I'll click on our function and I will give it an output. By default, it does a Boolean, which remember, we can just get rid of the default. And I'll take the out hit, drag it to the return node, and the return value, and give that to the return node. And I'll hit save and compile. Now, whenever I go to the event graph, I can simply, out of started, type in line trace, and look at that. Look how much more compiled and compact the line trace is, and we can still do whatever we want with the information without all of this happening. So let's pull this over, and you can see we'll just put the return value into there, and we'll get the out hit and put it into the break hit result. Plug the line trace into the branch, and that is much more compact. And now we can create another system that uses the line trace to put the prompt up without having to worry about this logic. We're going to use something called event tick. If you're new, just know that the event tick is fired on every single frame. So if you put a lot of load on the event tick, your game is going to run like garbage. It's very important to know what is okay to put on the event tick. If you're not sure, Google it or put it on there and see what happens. But I highly recommend just playing it safe. Google it and ask questions. It's the best way to learn. Besides breaking things, which, go for it. If you want to break stuff, go for it. But anyway, this is the long-winded way of saying only use the event tick sparingly. And since we're new to it and I'm explaining it, it also comes with something called delta seconds. Delta seconds is the real world time passing. Frame rate fluctuates. So for example, I might have 120 frames per second on my computer, while someone else is only getting 60, while someone else is only getting 30. However, the same amount of real world time will pass, but that doesn't mean the same number of frames have passed. So what the delta seconds do is allow you to adjust things based on how much real time has passed and not just the frame rate. I hope that makes sense. However, in this case, we're going to use it to line trace to check if the prompt should be on screen or not. So out of the event tick, we can now call our function for the line trace, and we have access to the out hit and the return value. So I'm going to go ahead and break that hit result. I'm going to create a branch by holding B and clicking on the event graph. I'm going to plug that return value into the condition. I'm going to open up the hit result. Out the hit actor, we are going to does implement interface, close the break hit result, grab both, press Q so it's nice and flush. We are looking for the interact interface, another branch, and boom. Does it implement the interact interface? If it does, well, we need access to that prompt from earlier, remember? That's why it's a variable. We are going to add to viewport. However, we're not going to do this on every frame. We can do the line trace on every frame because line traces are super easy on the system. I like to do math to make it so they only appear 4 times a second, regardless of the frame rate. But for the sake of this tutorial, we're going to let it happen every frame. It's not the end of the world. I'm just being a little nitpicky. But regardless, we can't make add to viewport at the end of this like this. What would happen is every frame we are looking at an actor that has the interact interface, it would add the prompt ref to the viewport. You can see where this is an issue because yes, it will overlap. There will be thousands of interacts on screen stacked and we wouldn't be able to see it, but our computer would eventually start to feel the weight of that. Plus, that's ridiculous. So instead, pull out the add to viewport. And instead, the prompt ref we're gonna pull out and we're gonna type in is in viewport. Boom. So basically what this is gonna do is if it's already in the viewport, don't do anything, right? Like just stop. So we can take the false and plug it into the viewport. Because if it's not, we need it added. If it is, don't add it again. And then out of the false on this branch, so does it implement the interface? If it doesn't, we're gonna do that branch again. Let's move things around here so it's a little easier to see what's happening. So if it doesn't have the interface and it is on screen, we want to get another prompt ref here. It's the same prompt ref, I'm just grabbing another one so it's not as cluttered. I'm gonna pull it out and I'm gonna say remove from parent. So when you remove from parent, the parent is the viewport. So does it implement the interface? Yes, it does. Okay, but is it on screen already? No. Okay, add it to the viewport. Does it implement the interface? No. Is it already in the viewport? Yes. Okay, well then you need to remove it from parent. And all right, there we go. We've got line trace as a function with two different events doing two completely different sets of logic thanks to the help of functions. Let's go ahead and save and compile. If you're following along, you probably got an error too. Make sure the prompt ref is the target, of course, to the thing we're adding to the viewport. Let's go ahead and hit save and compile. Let's hit play. And the first thing you'll notice is we're gonna get so many red lines, and that's because we are doing a line trace by channel every frame. So this shows you how often event tick happens, okay? Imagine if you put a ton of calculations on your event tick. You see where your game would begin to crash? Anyway, let's get close to the box and see if the prompt appears. It does. Let's move our mouse away from it. However, the prompt does not ever go away. Wait, what? So after the test, I realized there's actually a small issue when it comes to the prompt. With the prompt, we can't actually plug in this branch. You might be wondering why. Well, if we need to clear that we're not looking at an actor anymore, we need to make sure that it doesn't matter if we're actually hitting a target or not. So even if we're not hitting a target, we still need to be able to clear the widget from the screen. So make sure on this one, we're not checking to see if we've hit an actual actor or not, because it doesn't matter. So let's go ahead and hit play again. And now you'll see that if we hover this, we get press F, but when we look away, we no longer see press F. And of course we can press F. And then for some reason there's two here. I don't know why. This episode was extremely dense. If you need to watch it multiple times, do not feel ashamed. I had to do these 100 times before I fully understood them. So anytime something seems difficult, anytime you're like, I can't follow, know that you're not alone. In fact, most of the people that are probably watching this series are also struggling as well. So if you need help, always feel free to leave a comment. And remember that this stuff is hard and you're awesome for taking the step forward to do something challenging. For now, like, comment, and subscribe, and I'll see you guys in the next episode.